Hello, this is Omer and Bar, and we are glad to present our final Java project. Our project is a 3D maze game with several features. The maze has two built-in solve algorithms that can be chosen to solve the maze according to the setting defined by the user. Let's get started. This is the strategy design pattern, a design pattern that we implemented in our project. In one hand, we have the problem, which could be multiple kind of problems, such as a maze problem, parking lot problem, and etc. Each of those problems have a common ground that presented by an interface called searchable, which provide a generic conventional method to present the problem. On the other hand, we have our algorithm which should solve any kind of problem. The algorithm also have a common ground that present by a searcher interface that receive any type of searchable. Each algorithm will implement the search method and solve the problem in its own design. The BFS algorithm provides the fastest way to the solution. The calculating time to this solution of this algorithm isn't the fastest, but it's always return the shortest and the most accurate solution. This algorithm pattern works by pulling from the queue a neighbor with the lowest cost from a start position and adding his neighbors to the queue and repeat. By this, the algorithm ensures that the chosen solution will always be the shortest path. The DFS algorithm, in contrary to the BFS, DFS working by pulling the highest neighbor in the queue. It provides a shorter time to find the solution, but not always provide the best path from the start position to the goal position.
This is the architectural design we use in our project. The MVP architectural design is designed by three different layers: model, view, and presenter. This design provides the capability of independent layers developing. For example, if different programmer is also working on the view layer, it doesn't prevent from others to change the other layers. Every layer is responsible on different keyset in the program's lifecycle. Let's start with the view layer. It's responsible to get the commands from the user and forward it to other layers, and to display the returned values from the other layers to the user. Now we have the presenter layer. This is the only active layer in this model. This layer is responsible to operate and manage the data between the other layers. For example, when the model layer finishes its calculation, tell the presenter that the calculation is ended. Then, the presenter will grab the returned values and pass it to the view layer. Last but not least, we have the module layer. It is responsible to all calculation and running algorithms, the save and load, and also responsible to handle all of the threads. Now, let's get started. Let's start off by running our project. This is the main window. We have generate button, we have load, we have solve, hint, properties, and exit. In the properties window, we can select the number of threads, we can select the maze path, we can select the solve algorithm and the generating algorithm. Let's create a new maze and enter the size we want. Let's make it by 10. The user can navigate through the arrows. We can go up, down, left, right. You can go one floor up by the page up button and one floor down by the page down button. If the user needs help, you can use the hint to get one step closer to the finish line. If the user gives up, you can use the solve button, which will solve automatically the maze. But let's say we exit in the middle. Now we're gonna run the project again, and since we have the automatically save feature, we can load the maze, and we're gonna be in the last stop right before we exit. Now we can solve the button, and it's gonna finish the rest. Alright, when we close the maze, or actually the program, we're gonna make sure no threads remain open. So we can go to debug mode and see no threads remained open.